Graphing a feasible region. So in order to graph a feasible region, it's just like graphing a compound linear inequality. Very few differences. One, we're going to always have 3 or more inequalities if it's a feasible region. The other thing is that these are always intersection problems. So they're a little bit easier because we don't have to decide whether we want the entire shaded region or the overlap. We always want the overlap. So the first 2 conditions that I have are that x is greater than or equal to 0, which means that x is non-negative, and y is greater than or equal to 0. So y is non-negative. Basically, when you have these 2 conditions, x is greater than or equal to 0, and y is greater than or equal to 0, that's telling you that you want the first quadrant. So I'm going to go through and lightly shade the first quadrant. Alright. Our second condition is x plus y is less than or equal to 5. So I want to get this in slope-intercept form. So I subtract x from both sides. That gives me y is less than or equal to negative x plus 5, which gives me a slope. That negative x is really negative 1x, so that's negative 1, or negative 1 over 1. And my y-coordinate of my y-intercept is 5, so I get 0, 5 for my y-intercept. So I go to x is 0, y is 5, and I put a point. And then I go down 1 over 1. And then again, down 1 over 1. Down 1 over 1, and we just keep doing this until we have a sufficient amount of points. Now, since all I care about is that first quadrant, I don't have to extend my line off this way and off that way. So I'm just going to draw my line as it is right now, as it passes through that shaded region. So I know that this is a inclusive inequality, less than or equal to, so I use a solid line. And then it's y is less, so I shade below that line. So once again, as I go through here, I'm not going to shade real dark. I'm going to keep it kind of light because I've got another condition to graph. So what I have right now is this kind of right triangle shape where both my first 2 conditions, which left me with only the first quadrant, and then my second condition gave me this line, and I wanted it shaded below that line. And that's developing this triangle here. I've got one more condition, or inequality, that I want to graph, and that's going to further restrict that shaded region. So I want to get it in slope-intercept form. So I subtract x from both sides. That gives me 2y is less than or equal to negative x plus 6. Then I have to divide by 2 throughout. And that'll give me y is less than or equal to, now that negative x is a negative 1x, so that's negative 1/2 x plus 3. So my slope is negative 1 over 2, and my y-intercept is 0, 3. So I go x is 0, y is 3, and I put a point, and then I'm going to go down 1 and over 2, 1, 2. And then down 1 and over 2, 1, 2. And then I'm going to go down 1 and over 2 again. Alright, so that is an inclusive inequality because it's less than or equal to. And sometimes you can wind up losing your dots, so let's make sure that our dots are really well drawn. Okay. And now to shade it, it says y is less than or equal to. So we want to shade below that line. Now, you'll notice that our shaded region is currently right here. So the easiest thing to do is just shade here. This little area that we've got right there, that's not going to be in the overlap, so we don't need to shade it. We're just going to shade everything that falls under our third condition that's still in our overlap. So what I'm shading in right now, I'm shading in very darkly because it meets all four of these conditions that we were originally given. Alright, so just to kind of recap, we had our first two conditions, x is greater than or equal to 0 and y is greater than or equal to 0, and that limited us to quadrant 1. Then we had our second condition, x plus y is less than 5, and that's what gave us that triangular shape that we saw as our overlap. The last condition, x plus 2y is less than or equal to 6, gave us this line that we saw passing right here, but we didn't need to shade in that portion because it was not in our original overlap. So we just left it. And that's it.